Okay, so we're going to go over these one question at a time so that you understand how to do this. All right, so this is the first question on the district assessment. These are going to be similar to what you're going to see on the test, obviously not the same. All right, so first, reading our question, we have to determine whether the graph of the equation will be parallel, perpendicular, or neither parallel nor perpendicular to the line shown, right? So a couple things that we need to remember, and I will just type them so that you can see. Parallel lines will have the same, slope, right? So we need to have equal slope. If two lines have equal slope, they are parallel. Perpendicular lines, they are like completely opposite, right? So parallel lines are two lines that are never going to touch, right? So if we have a line there and we have this line, I'm just drawing it so I know that it's the same slope, right? Those two have the same slope. And anywhere I move that line on here, those two lines would be parallel, right? That's the point. So they have the same exact slope. Well, the perpendicular, I want to do the exact opposite, right? And I won't be able to do this very well showing you, but just as a demonstration, actually, I'm lying. I could make it actually exactly, right? So if I have one here and three, all right. And we're going to go over this in just a second, but I know those two lines are perpendicular, right? Their slopes are going to be the exact opposite, right? So they're negative reciprocals, right? So negative reciprocals. So, well, we have to find the slope, right? So maybe what we should do now, and then if the slopes are negative reciprocals, then they're perpendicular. And then if they're neither of those things, then they're neither of those things, right? Okay, so we need to figure out what the slope is. We're going to go to our trusty old equation. We have a line here, right? Our line is going to be y equals mx plus b. That is always the equation of a line. I know you know this. I'm just going to be very explicit with everything so that we know what is happening where, right? So when we're looking at this equation is going to tell us everything we need to know on how to graph it, right? My B, probably shouldn't be the same color. My B is going to be where it crosses my y-axis. It's my y-intercept there, right? So this is crossing at -4. That's what my B is. My x and my y are just regular old coordinates, right? They change as it moves along the line. So we're just going to stay here, and you're going to see me very slowly type it. I should probably see if my finger will work. Okay, so we know the x and the y are going to change, right? Like in this spot here, is this going to work? Does it want to work my finger? Right. Ooh, I just already saw that line. Okay, so in this spot right here, I don't trust myself. X is 0, y is -4. In this spot right here, x is 3, y is -2, right? So this is the point 3. Oh, come on. -2. All right, maybe it's not so. It's kind of legible. -2. Okay, we'll do it that way, right? So as x and y moves, it does that. That's why the x and y always stay as a coordinate. Anyways, what this m is it is the slope. The slope is your slope, remember? Oops, we're going to have terrible handwriting. Is your rise over your run, right? So how much is it going up versus how much is it going over, right? Those are the things we're looking for. All right. Okay, so how much is it going up? Arriba, right? It's going up 2. So my rise is a positive. It's moving in the positive direction. If I want to put that sign there, I can, right? My rise is 2. My run, how much it's running over, is running over 3. Therefore, my slope is 2 over 3. Okay, 2/3 x minus 4. Okay, that is the equation of that line. The b comes from where it crosses the y-axis. Your slope comes from how much it goes up versus how much it goes over. All right. Now, up here, we have parallel lines will have the same slope. So anything that has a slope, when my slope is 2/3, right? When that coefficient of x is 2/3, then it's going to be parallel to this line, right? That b can be anything else. It should be anything else. If it's -4, it's literally the same line. But if it's anything else, then those two lines are going to be parallel. Now, if I want a perpendicular line to that, right, my slope, I have to have the negative, right? So this one is positive. This one's a positive number. So this one's going to be a negative number. And then it's reciprocals, right? So it's instead of 2/3, it is going to be 3/2. Okay. So anything that has a slope of -3/2, it can actually have the same y-intercept in this one, but regardless, anything that has a slope of -3/2, that's going to be perpendicular. Okay. So looking at this problem, what it's going to ask us to do is find which ones are parallel, which ones are perpendicular, and which ones are neither, right? All we have to look at is the slope, right? So for that first column of parallel, I am only looking for things that have a slope of 2/3. Oh, is that going to do it? No, I wanted to do something else. Hold on. This. I wanted to highlight. Oops. You can't tell the difference there because that's a light peach. That's ridiculous. But anyways, 2/3, right? So let's look at all of our slopes. That's the number that comes in front of the x. Ooh, there's one, right? This one is parallel because I'm looking for that slope and it is 2/3. Okay, do I want to keep marking these? No. So, well, I'll stop it. All right, so that's not the same. 2/3. Okay, that one is parallel. 3/2. Nope, not the same. -3/2. Nope, not the same. 1/2. No, not the same. And a slope. What is that slope? Oh, yeah. What could I multiply x by to keep it the same number? I can multiply it by 1. So that's not it either. All right, so those are our two parallel slopes lines, right? If I'm looking through here for my perpendicular, do I want to erase these? Sure. Right? I'm always looking at those, though. Different color. All right. Yes. Because I'm looking for -3/2. This is a +3/2. That means it is not perpendicular. Therefore, it must be neither. All right. We already know that one's parallel. This one is -3/2. That is perpendicular. All right. We know that one's parallel. Look down at the next one. It's a +3/2. Nope. I need it to be a -3/2. All right. Like this one is a -3/2. Cool. That's perpendicular. 1/2. What? Has nothing to do with it. Neither. And then our 1 again is neither. Okay, so in ones like this, we have to actually find the equation of the line. And actually, do we have to find the whole equation of the line? No, we only care about the slope on this one and something like this. I don't care that it's, it's always good to know, right? Good to know the whole thing and not just part of it, but you really are just comparing slopes here. So all in that one is find the equation, find the slope of that line, and then if it's the same, it's parallel. If it's the exact opposite, it is your negative reciprocal. It is perpendicular. Otherwise, it's neither.